Hello everyone, I am Abdessalam Ouaazki, and in this presentation I will present our paper entitled Care-Based Eco-Feedback Augmented with Generative AI, Fostering Pro-Environmental Behavior Through Emotional Attachment. This paper is co-authored with my distinguished colleagues Manon Berney, Vladimir Macko, Bruno Kocher, and Adrian Holzer. Our paper introduces a novel care-based eco-feedback system to fight the escalating energy crisis. Did you know that on average, each one of us globally consumes about 60 kilowatt hours of electricity every day? That's more or less the equivalent of leaving a light bulb on for 40 days straight. That's a lot, but there is some good news. Research shows that digital interventions can potentially decrease our consumption by 5% by making us aware of our energy usage. That is why digital interventions have become more and more common, even more today with the possibility of linking them with real-time data linked to smart meters. However, most systems primarily rely on statistical visualizations to provide feedback, which might not be the most effective in encouraging energy-saving behavior. Critics also argue that those systems often oversimplify the complexity of human engagement with sustainability and focus too much on data-centric aspects. And finally, feedback systems tend to be less successful with individuals who are less environmentally aware. This raises important questions about how we design and implement digital interventions to ensure they are inclusive and effective for all individuals. We thought of a new solution, creating a system that fosters emotional attachment with the user. In this research, we explore this idea with the following research question. Can care-based eco-feedback lead to higher emotional attachment and increase pro-environmental behavior, even for less environmentally aware people? To do so, we created a system designed to give feedback to users on their energy saving levels with an avatar named INFI, who takes its life force from the energy saved by the user. The avatar changes appearance based on how much the user can save energy. If a user's energy saving level is low, the avatar has a livid and sad appearance. As the energy saving level increases, so does the avatar's vitality, until it becomes happier and more energetic. Here is an overview of the full system. On the left side of the screen, next to the avatar, there is a gauge that gives a standard visual representation of the energy saving level. The avatar is in the middle of the screen, and on the right, there is a possibility to chat with the avatar. When the user starts the experiment, the system asks him or her 6 simple questions to evaluate their level of energy saving. An example of question could be, how often do you switch off lights when you are not in the room? The user replies with predefined answers, never, rarely, sometimes, often, or always. Once done, the user has the possibility to chat with INFI and get some advice on how to save energy. The answers of the user increase the energy level of INFI proportionally. The more the user talks with INFI, the more energetic INFI becomes. For the experiment, we created 3 groups. A control group that has no avatar and no chat, only a gauge and written advice. The care-based group with only the avatar but no chat, and the Gen AI care-based group with an avatar and a chat. In the following slides, we will present our results. Our first hypothesis was about whether increasing emotional attachment leads to an increased behavioral outcome. As you can see on this slide, our psychological outcome is emotional attachment, and the behavioral outcome was measured through energy-saving intention and donation for an energy-saving organization. We verified this model using a PLS path analysis. Our results show that emotional attachment is significantly associated with the behavioral outcome. This means that the more participants got attached to the system, the more they intended to save energy, and the more they donated for an energy saving association. So our first hypothesis is verified. And in a follow-up study, we verified the same model using participants' reported energy saving behavior that we measure 3 months later. And the model still holds, as you can see in this slide. Our second hypothesis was aimed to investigate if care-based and conversational designs can lead to an increase in emotional attachment. For this, we compared emotional attachment scores across the 3 experimental groups. Our results indicate that as we go from the control to the care-based and to the Gen AI care-based groups, emotional attachment significantly increases. This means that the introduction of an avatar increases emotional attachment, and the introduction of a Gen AI conversational agent even increases it further. Our second hypothesis is also verified. In the third hypothesis, we checked if emotional attachment leads to an increased behavioral outcome for individuals with lower environmental awareness. Our results show that for lower emotional attachment scores, there is a significant difference between the more and the less environmentally aware people in terms of energy saving intention. However, as emotional attachment increases, this gap decreases until it becomes insignificant. This means that a higher emotional attachment to a system particularly encourages the less environmentally aware people to save energy. And as such, our third hypothesis is also verified. Finally, I will present some quotes from our thematic analysis, starting from quote that indicate reactance to energy saving, in which one participant indicated a very simplistic and gaslighting system that attempts to shame you for personal behavior when governments and corporations are left unchecked. To more positive comments, such as this user who noted, "The system is fun to use, it gives great advice, and makes me feel proud of myself when it likes my answers." And this participant who noted, "My interaction with the system gave me a reason to reconsider my attitude and behaviors towards energy saving." Finally, here is an overview of our paper. We invite you to read it, and we'll be glad to connect with you should you send us an email on the email addresses you can see on the screen. And I conclude this presentation by showing some of our most notable references. Thank you very much for listening and for following this presentation.